Section 5-7, the Pythagorean Theorem. The objective of this lesson will be to use the Pythagorean Theorem and its converse to solve problems, and to use the Pythagorean inequalities to classify triangles. Now you're all familiar with the Pythagorean Theorem, and here it says in a right triangle the sum of the squares of the leg is equal to the square of the hypotenuse. And you all know this as a squared plus b squared is equal to c squared, where c has to be the length of the hypotenuse and a and b could be either leg. Let's go ahead and do our first example here. We have a right triangle inside of this rectangle. The measure of the two legs is 12 and 16 units, and they're asking us to find the hypotenuse, c. So if we plug in the legs, 16 squared plus 12 squared, that will equal the hypotenuse squared. And when we work this out, we get 256 plus 144. And when we add those, we get 400. And to get rid of the squared, we take the square root. So that tells us that c, our hypotenuse, is 20 units. So this all should be reviewed from middle school and from stuff you've done last year as well. Now there are some special numbers that we call the Pythagorean triples, and these will always work out to be right triangles. Our first one is the 3, 4, 5, and the multiples of these are also considered Pythagorean triples. So if you take 3, 4, 5 and you multiply it by 2 to get 6, 8, 10, that right there, those units, if you do a 6-inch, an 8-inch, and a 10-inch triangle, that will make a right triangle. Another one is 5, 12, 13, 8, 15, 17, 7, 24, 25. You don't have to know all these. The one that's most commonly used is a 3, 4, 5 triangle. So 3 units by 4 units by 5 units triangle. So let's go ahead and talk about the converse of the Pythagorean theorem. You've all heard the Pythagorean theorem. You know that the legs squared equal the hypotenuse squared. The converse says that if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the third side, then the triangle is a right triangle. So if you plug these numbers in and it does end up equaling, if the left side of the equation equals the right side of the equation, then you can say that this triangle is a right triangle. Now we do have Pythagorean inequalities. This is our Pythagorean inequality theorem, where it's not always going to equal the length of the hypotenuse. If you look at the side on the left, it says if the c part is greater than a squared plus b squared, then you have an obtuse triangle. The other inequality theorem says that if c squared is less than the sum of a squared plus b squared, then you will have an acute triangle. Okay, so if you look down at the bottom, the first one is a right triangle. The one in the middle, this is an obtuse triangle, so angle C is going to be greater than 90. And then the one on the right, the C angle is going to be less than 90, so you will have an acute triangle. Let's go ahead and try out some examples. First one says, classify the triangles as acute, obtuse, or right. So we're going to plug these in to a squared plus b squared, and we're not going to know if it's equal to, less than, or greater than. That's what we have to figure out, to c squared. Now c is always going to be the longest side of the three numbers, the biggest number. So on number 1, 16 will be c, and 7 and 12 are a and b. So we're going to take 7 squared plus 12 squared equals 16 squared, or we're not sure if it's equal. If we work it out, we get 49 plus 144, something 256. If we add 49 and 144, we get 193, which is less than 256. Okay, now because the left-hand side, the a squared plus b squared, since that side ends up being less than 256, we know that we have an obtuse triangle. Let's try example number 2. Once again, C is going to be 5.2, and A and B will be 3.8 and 4.1. So when we plug this in, we want to know if it's going to be less than, or greater than, or equal to. If we were to plug this in the calculator, we get the following. And then when we add everything on the left side, we get 31.25, which is greater than 27.04. And because the left side of the equation is greater than, this tells us that we have an acute triangle. Okay, so you have to remember which side has to be greater. If c squared is greater, then that means it's an obtuse triangle. If a squared and b squared is greater, then you have an acute triangle. Okay, the last one. Remember, c is going to be 50 because that's our longest length. That means 30 and 40 are a and b. If we work this through, we get 900 plus 1600, and on the right side we have 2500. And when we add it, we see that both sides are equal. And because both sides are equal, that means that we have a right triangle. Okay, we're also going to combine this lesson with section 5-8. We will be applying special right triangles. Special right triangles, here's our first one, which is the 45, 45, 90 triangle. And the theorem on this one, basically what we're going to be looking at is this picture on the right side. This picture tells you how to solve the missing sides of a 45, 45, 90 triangle. It's called that because of the angles. It has two 45-degree angles and a 90-degree angle. And if you notice, across the 45-degree angles is the letter L. Those two sides are the same length because they both are across an angle that measures the same. And across the angle C, that leg, the blue side, that's your hypotenuse, is L square root of 2. So it measures longer than side AC and BC. So let's go ahead and see how we use this to solve a problem. Let's take a look at number 1. Notice I put the theorem, the picture that's in the theorem right here in the middle. And if we look here at problem number 1, I'm looking for the length of the hypotenuse. I do know that the side across 45 measures 8 units. Now if I compare that to my theorem across 45, and notice there are two 45s, and it doesn't really matter which one you go across, but across 45 is the letter L. That means that 8 equals L. Now because 8 equals L, I already know what the variable is, and I can fill in the rest of the theorem, which has these letter L's, and just plug it in. Across the right angle, which is the hypotenuse, they want me to solve that side. They're calling it x. If I look at my theorem, it says that side is just equal to L square root of 2. Well, I know what L is, so all I have to do is plug it in. So I know that the hypotenuse measures 8 square roots of 2. So x equals the same length as the hypotenuse on the theorem. All I had to do was plug in the letter L. We know that L is equal to 8. So I get that the hypotenuse is 8 square roots of 2. Let's go ahead and try another one, number 2. In problem number 2, I know that the hypotenuse is equal to 5 units. And if I look at the theorem, the hypotenuse is equal to L square roots of 2. So 5 is equal to L square roots of 2. I want to solve for the variable L so that I can plug it into the missing sides. To get L by himself, I have to divide both sides by the square root of 2. And when I do that, I get that L is equal to 5 square roots of 2. And for right now, we're going to leave it this way. We will teach you how to simplify this radical. We do not like square roots to be in the denominator, but we will show you how to do that when you get back from your Thanksgiving break. So since L is equal to 5 over square roots of 2, notice L in the theorem is across the 45-degree angles. And if we look at our problem, across the 45-degree angles is our variable x. Those sides have to measure what says in the theorem, which is L. So both of those sides are 5 over square roots of 2. Okay, our next theorem for section 8 is your 30, 60, 90 triangle theorem. This triangle has a 30-degree angle, a 60-degree angle, and a 90-degree angle. And once again, we're going to pay attention to the picture on the right side, and it's going to tell us where or how long each side measures. And notice the variable here is s. if we can find out what S is, we can fill in the rest of the side lengths. So here's one of our next examples. Notice I put the theorem again in the middle so that we can use it and compare it. On problem 3, we know the length of the hypotenuse. The hypotenuse is equal to 24. If I look at the theorem across the hypotenuse, that length should be 2s. So I know that 24 has to equal 2s. I need to solve for s, so I need to divide both sides by 2. When I divide both sides by 2, I get that s is equal to 12. So now that I know what s is, I can plug that into the rest of the theorem, so the rest of the sides, and I can find the missing side lengths of this problem. If I look across the 30-degree angle, that's the side that they're calling x, and in the theorem, across the 30-degree angle is s. So that means that that side just measures the value of s, and we figured out that was 12. Okay, and then the next side is y. That side is across the 60-degree angle. If I look at the theorem, across the 60-degree angle, it says s square root of 3. So all I have to do is plug in the value for s, and then put a square root of 3 next to it. Well, we know that s is 12, and if we put a square root of 3 next to it, that side measures 12 square roots of 3. And we're done. Let's take a look at problem 4. Problem 4, we know that the side across the 30-degree angle is 5. Once again, we're going to look at the theorem. The side across the 30-degree angle is labeled s. That tells me that 5 must equal s. So now we have to find the length of the hypotenuse and the length across the 60-degree angle. Let's go ahead and start with the length of the hypotenuse. Look at your theorems. The length across the hypotenuse is 2 times s. Well, we know what s is. If we multiply that side by 2, we will get 10. So the value of the hypotenuse is 10 units. Next, the side across the 60-degree angle. Okay, they've got that labeled as x. We're trying to figure out what that is. Across the 60-degree angle in the theorem is s square root of 3. We know what s is. We can just plug that in and then just put the square root of 3 next to it. So that means that x is equal to 5 square root of 3. And then we're done. We have found the missing length. So all you have to do with these triangles is just figure out what the variable is, and once you know what that letter is, you can just plug it in and find the measures of the other sides. Write down and draw these triangle figures, your theorem, so that you know what the side lengths are. Make sure you label the appropriate sides. Don't mix up the measures of the side across the 30-degree angle or the 60-degree angle. And make sure you can read these pictures because you will be using them for this week.